This is the tetrachloromethane. The common name, carbon tetrachloride. Because now I just have a carbon here and I have a tetrachloride. You might have heard of carbon tetrachloride before. Your parents and your grandparents, when they took their suits and dresses into dry clean, they dipped it in carbon tetrachloride. Because it's a great solvent. They just had big vats that they dipped it in, they pulled it out, it evaporated, it took all the dirt and grime off your suit and left it really nice. The problem is it's carcinogenic. And it's and so the carbon tetrachloride, it is a wonderful solvent. And I mean, if you want to clean something, get some carbon tetrachloride. Okay, it's great. Okay.
Cleaning.
Yeah. Okay, so that's nomenclature. Let's talk about classification. We sometimes like to classify our alkyl halides because we know in the next chapter that whenever we have an E1 or an S1 reaction, if we have these halides are good leaving groups and they can leave us a carbocation, so we can predict whether we're going to have a tertiary carbocation, a secondary carbocation, and a primary carbocation. And so in this case, these are really simple, right? How many carbons is this carbon attached to? 1. That means it's a primary carbon. That means it's a primary alkyl halide, haloalkane. Either one of those two. This one, carbon's attached to 2 carbons. It's a secondary carbon, therefore it's a secondary alkyl halide. And the same thing here. This carbon is attached to 3 other carbons. It's a tertiary carbon, so it's a tertiary alkyl halide. How about these two down here? Remember that? We talked about geminal and vicinal? Because some of the reactions that we do happen differently if I have 2 halogens on a molecule, and whether they're on the same carbon or if they're on adjacent carbons, right next to each other. What's this one called? We're talking about that right now in class. That vicinal or geminal? Vicinal. They're in the vicinity of each other. Okay? That's the only reason I remember it. And geminal, this means they're on the same carbon. Geminal, I don't have a good analogy for that one unless somebody comes up with one.
Gemini, like the twins, the Gemini sign?
Gemini twins. Twins on the same, from the same egg. Okay. Ah. Okay. So that's all there. This one's geminal. This one's vicinal. Again, you can predict chemistry based on whether you have geminal dihalides or if you have vicinal dihalides. That's why we're learning those terms. Okay? Let's go on to the next. More of this nomenclature. I know Dr. Sadhu is going to have some nomenclature on there. Organic chemistry test would not be an organic chemistry test without some nomenclature. Let's find the longest carbon chain here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got to be a decane, right? Okay. Then we got to look at where we hit the first substituent. I can really tell pretty quickly that I go 1, 2, 3, 4. I'm going to be a 4-bromo. Is that a chiral carbon? Why not? It's got 4 different groups attached to it. The problem is that I have not told you whether it's the R or the S isomer of that carbon. So there's no way for you to tell and how to name that. Okay? So in this case, we could think of it as being the racemic mixture because it's not actually identified as coming out at you or going back into the board. So I haven't shown any stereochemistry here. So I'm going to have a 4-bromo, a 5, 1-fluoropropyl decane. 4-bromo, 5, 1-fluoropropyl decane. Again, when I talk about substituents, that carbon which is attached to my longest carbon chain, that's always carbon number 1. So it's 1-fluoro, 1, 2, 3, that's a propyl group.
And in that case, the 1 is important to include, right?
Say it again, please.
In that case, the 1 is important to include. Because
Oh,
some of the
yes.
other examples.
Yeah, because this fluorine could be at carbon number 2 or carbon number 3, right? It would be a completely different compound. How about this carbon right there? Is that carbon chiral? do know. It's a chiral carbon anyway. We don't know which chirality it has, right? How about that carbon right there? That's chiral too. But we just don't know. Imagine if we had put stereochemistry in there. It again makes the nomenclature system pretty complicated. If you sent this molecule into the IUPAC committee, they have people getting paid six-figure salaries to come up with these names. Yes, you know? And they actually sit down and review. If you made a new molecule, they'll review that, make sure you named it right. And then they argue about it, and then, you know, they give you approval, they give you a number, okay, that you can assign your molecule to. Not only are molecules actually defined by their name, they actually have a number, a CAS number. That every single molecule that is known gets a CAS number when it's either identified or isolated or named, okay? So that one. This one right here, ooh, I am showing stereochemistry right there, right? So we're going to have to see if they're chiral first. If they are chiral, we're going to have to name them as R and S. So I look at this one, and I have a six-membered ring. That's going to be cyclohexane. I have a chloro group, and I have a isopropyl group. Or I could have called that a 1-methyl ethyl group, right? Either one is fine. You can use the more common nomenclature, or you can use the IUPAC systematic system. Both are approved by IUPAC. And so then we need to decide what the stereochemistry is again. I know the chlorine is probably highest priority. The hydrogen going into the back of the board is lowest priority. Thank goodness. It's in the back. I go 1, 2, 3. So that's going to be an R. So it's going to be 1 R, 1 chloro. I look at this one, 1, 2, 3. I'm going to have my isopropyl group coming out of the board there. So I go 1, 2, 3. That's going to be the S isomer because my hydrogen's back into the board. Okay, so that's going to be a 3 isopropyl or a 3, 1 methyl ethyl group. Everybody seeing that? Those two nomenclature systems there? Okay, we put all that together. I get 1 R, 3 S, 1 chloro, 3, that's 1, 2, 3, 1 methyl ethyl cyclohexane. Yes?
I was just gonna say, so could you just clarify how we know exactly the priorities? I know you have to visualize
Yes.
the hydrogens, but it's kind of hard to tell that you go
In these
right.
systems here with chlorine, it's alphabetical.
Okay, so like when you went to the right, you said that.
Oh,
second
I see what you're
priority.
saying. Yes. Okay. Okay. So if I start here, let's call that 1. I got, this is my highest priority, the chlorine, right? My hydrogen is the lowest priority. And then to determine next priorities, I move 1 carbon out. And if these are both carbons, and they're the same, right? I move 1 more carbon out because these are just 2 hydrogens too. I move 1 more, I get CH2, I get CHC. So that becomes highest priority. So you just keep on moving out along the carbon chain until you either hit a heteroatom or you hit more carbons. Okay. Yes?
So when like one of the groups, the stereochemistry isn't shown, you just like when so like the hydrogen isn't shown on there, do we just assume that it's the opposite?
It has to be.
Yeah.
Yep. It's always assume that. And we never hardly ever show the hydrogens. In some cases we do, but not always, right? They're always assumed to be the opposite of whatever is shown. Because it's got to have 4 bonds to each one of these carbons here. So there's got to be 2 hydrogens here. There's got to be 1 here. There's got to be 1 here. There's got to be 1 here. 3, 3, 2, 2, 2. Yes?
Say the isopropyl was on the bottom of the ring, like,
Isopropyl.
well, the.
If you'd moved it one
Oh, on
carbon
the bottom?
Yeah, say you moved it like to the bottom,
Yep.
would it make the Cl non-chiral then?
It would.
That carbon, sorry.
Yes, because your groups would be identical going around the side. It's a good point. Because then you hit the same carbons on both sides. It's symmetric, and so it's not chiral. And the other one's not chiral also. Because you could draw a mirror image that is superimposable just by flipping it over. Okay? Okay. So if I look at this molecule right here, what's my longest carbon chain on that one? Cyclopentane. I have a substituent which is a cyclopropyl, cyclopropyl. cyclopropane. When it's a substituent, I put the ill on there, right? And I have 2 iodides. Those are going to be iodo substituents. And notice that I've actually drawn here stereochemistry. Okay? So if I look at that one, can I name this one R or S? If I look at this, yeah, I can. Okay? If I look at this one, my hydrogen is coming out of the board now, right? And this carbon right here. So if I look at this one, my highest priority would be going down this way, because that's